Uh, Hi students, today I'll be discussing an important test most of the times we use in our empirical research, that is T distribution. A hypothesis test that uses the T distribution, a univariate T test is appropriate when the variable being analyzed is interval or ratio. A univariate t-test is appropriate for testing hypotheses involving some observed mean against some specified value. What is this t distribution? In the statistics you might have seen this. A symmetrical bell-shaped distribution that is contingent on sample size has a mean of 0 and a standard deviation equal to 1. Like the standardized normal curve is a symmetrical bell-shaped distribution with a mean of 0 and a standard deviation of 1.0. Therefore, while the t-test is strictly appropriate for tests involving small sample sizes with unknown standard deviations, researchers commonly apply the t-test for comparisons involving the mean of an interval or ratio measure. The precise height and shape of the t distribution vary with the sample size. More specifically, the shape of the t distribution is influenced by its degree of freedom. At this point of time, let me ask, do you remember what is this degree of freedom? What is this degree of freedom? The number of observations minus the number of constraints or assumptions needed to calculate a statistical term. So the degree of freedom are determined by the number of distinct calculations that are possible given a set of information. In the case of univariate t-test, the degrees of freedom are equal to the sample size minus 1. Right? So we will be discussing, we have in the statistical hypothesis test, we have one more important concept, that is one-tailed and two-tailed tests. When the region of rejection is on only one side of the sampling distribution, what is that? When the region of rejection is on only one side of the sampling distribution is called one-tailed test. For example, null hypothesis states that the mean is less than or equal to 10. The alternative hypothesis would be that the mean is greater than 10. The region of rejection would consist of a range of numbers located on the right side of the sampling distribution, that is, a set of numbers greater than 10. So, a test of statistical hypothesis where the region of rejection is on both sides of the sampling distribution, which is called a two-tailed test. So, for example, suppose the null hypothesis states that the mean is equal to 10. The alternative hypothesis would be that the mean is less than 10 or greater than 10. So, the region of rejection would consist of a range of numbers located on both sides of the sampling distributions. So, that is, the region of rejection would consist partly of numbers that were less than 10 and partly of numbers that were greater than 10. I hope you might have understood what is this one-tailed test and two-tailed test. Thank you.